Since the start of this rebuild, the goal has been to make the boat future-proof. And while electrifying boats and ships is not really a fully developed business yet, this is exactly the right moment. Diesel prices are surging, so every liter we save is profit. My name is Gijs and this is my dad. And this is Schoener Tijgerhaai. 3 years ago we started a major rebuild to get her ready for new adventures. And we're sharing the process with you. Subscribe to stay tuned. We have decided not to get rid of our old diesel engine. It is strong and reliable, so it would be silly to give that up. But we do want to add an electric motor, turning the whole propulsion system into somewhat of a hybrid drive. Space is limited and so is our budget. So we've been searching for a suitable solution that allows us to maneuver, motor at cruising speed and generate power from the shaft when using the diesel engine or when sailing. Which landed us at EV Europe, who specialize in EV conversions. Mostly cars, but also boats. And they could help us acquire most of the stuff we needed. They offer all kinds of new electric drives and used low mileage Tesla motors. But first we have to make some space. The area around the propeller shaft is used by the shaft seal grease system and an external lubrication oil pump for the gearbox, installed on each side of the shaft and driven by the shaft via a belt. If we shift it all to one side, we can free up the entire other side for the electric motor. The shaft seal has an automatic grease pump. When the shaft turns, the pump pumps a tiny bit, keeping it watertight. But there's also a manual grease press to give it some extra, or to fill it up after maintenance. To fit the automatic pump on the other side, the manual press needs to take up a little bit less space. Instead of having it angled, the plan is to install it pointing straight upwards. The other thing that's in the way is a belt-driven gearbox oil pump. The gearbox also has an internal oil pump which is driven by the input shaft. But when we're sailing, the propeller is freewheeling, so only the gearbox output shaft is turning. That is when the external pump has to be engaged. Which will also be applicable when we're going electric. Engaging the belt on a rotating shaft is always a bit tricky. And the piece of shaft that is driving the belt is exactly the part that we want to use for the electric motor. So we're gonna replace the shaft driven pump for an electric one. But now that everything is shifted to starboard and out of the way, let's see about that electric motor. EV Europe supplied us with this one, out of a used low mileage Tesla Model S. And they permanently locked the differential since we're only gonna be using one output shaft. It has a continuous output of roughly 35 kilowatts and a peak power of 220 kilowatts. And those numbers are fitted in a very small package. At cruising speed, we normally use 10 liters of diesel per hour, which translates to an average of around 50 horsepower, around 35 kilowatts. So that is perfect. And the motor has an internal reduction, giving it a pretty low output RPM. Perfect for our propeller shaft. dat die nieuwe ding er wordt gemaakt. Nee. Not bad, and there is space to spare. But first, while stuff is out of the way, time for paint. And to install a special toolboard. The new Gearbox oil pump is just a small electric motor and a separate pump, connected with a bell housing and a flexible shaft coupling. You can order these pre-assembled or just order the parts and put it together yourself for half the price. This is a single-phase electric motor, since on our current battery-powered inverter we only have single-phase power available. It fits right back in the position of the old pump. It just needs a new foundation. Alright, the moment of truth. A bit disappointing. I disassembled the whole thing again and noticed that the shaft of the electric motor was turning quite heavy, and it could not start the pump even without oil pressure. So I sent it back for replacement. The new one arrived 3 weeks later and had the exact same problem. So, after getting into a bit of an argument with the supplier about him selling me a motor for a pump that can't even turn the pump, he agreed to refund me the money for the motor. And I did what I should have done in the first place: buy a 3-phase electric motor from a reputable brand with a variable frequency drive. Those two combined are just $50 more expensive than a single-phase electric motor, but better in every way. 3-phase electric motors are cheaper but more reliable, and the variable frequency drive converts 1-phase input into 3-phase output. And as a bonus, we can now even change the speed of the pump. Anyway, back to the Tesla motor. It needs a strong foundation to keep it in place. Obviously, we need some kind of power transmission to get the rotational force of the Tesla motor into the propeller shaft. The Tesla motor runs at a maximum speed of 18,000 RPM, but it has an internal reduction gear of 9.34 to 1, so the output is around 1900 RPM. But that speed is not really its happy place. It is where a car would drive at its absolute maximum speed. And it's also not in its maximum torque range, which is from 0 to 5 or 6000 RPM. So from 0 to 550 RPM on the output shaft. Our propeller shaft turns at around 350 rpm at cruising speed. So we only need a small reduction of 1.5 to 1 to keep the motor happy. Although we could also do a ratio of 1 to 1. The trade-off would be lower motor RPM at cruising speed, which is good for efficiency, but we would need higher torque. Although the Tesla motor has a maximum output torque of 3000 Newton meters, which is similar to what our current diesel engine had when it was new after the gearbox. So what type of transmission is best? An extra gear wheel on the shaft and on the Tesla is not really convenient. The Tesla motor would have to sit very close to the shaft. Unfortunately, our gearbox does not have an extra input shaft to connect the electric motor to. A chain drive would be convenient because it is easy to replace a broken chain without removing the shaft. But apparently, for this application, the speed of the chain would be so high that it would constantly need to run through an oil bath, and that is very inconvenient around the propeller shaft. So that kind of leaves us with only one option, and that is a belt drive. The limitations here are the maximum size of a toothed belt sprocket at the motor, since it has limited space, and the minimum size of a toothed belt sprocket around the shaft. The good news is that ratio is around 1.5. We also have to take into account the available length on the shaft. Gates, a manufacturer of belt drives, has a very handy tool that lets you input all your restrictions, and the tool will give you a list of options. In this case, a lot of orange. I just played around with demands and restrictions until I had a solution that was good enough. With the maximum available length on the shaft, we are able to fit two 36mm wide toothed belts, or poly chains in Gates language. The maximum shaft torque is around 1200 Newton meters, equivalent to 43 kilowatts at cruising speed. So we're fine for cruising speed and maneuvering, but we'll have to limit the Tesla at that, and we won't be able to use the full 220 kilowatts of the Tesla, which is fine. If we need that much power, we have the diesel engine. The biggest challenge we have is that all these toothed gear sprockets have to slide over the shaft from one side. However, our intermediate shaft has a flange on each side, so that is out of the question already. It cannot be split, and split sprockets don't really exist for this purpose. So we have to do some very precise and accurate crafting to make split sprockets ourselves. But the first challenge is taking the intermediate shaft out. Theoretically, we can just take the bolts out, push the propeller shaft a bit back and lift the intermediate shaft out. We tried it with a chain block, but these are self-centering flanges, meaning one has a raised face in the center and the other one has a matching recess. That means they have to be separated by quite a bit to clear each other. Somehow a chain block separates them a couple millimeters, but not enough. So we spent some time creating a special tool to apply a bit more force and more parallel to the shaft. That did not bring us any closer. We tried to find out what is obstructing the shaft or where it's bottoming out. We ruled out the rudder, so maybe the shaft is running into a shoulder at the end of the stern tube. Anyway, we cannot check that while it's in the water, but there's no way back now. So it's time for a bit more drastic measures. Shifting the entire engine. We only needed a few millimeters and the shaft popped right out. And now that it's out, we're sending it off to a heavy machine shop together with the big toothed belt sprockets to do the first part of our precision job, machining them to fit together perfectly. And shorten the shaft a bit so that it can slide back in without shifting the engine the next time. Our own lathe is a bit old and not precise enough for the job. And while it was out, we decided straight away to replace the first two gland packings from the shaft seal. And this is probably the best time to give the bilge a fresh coat of paint. The parts returned from the machine shop and they did a fabulous job. So now it's up to us to get a bit radical. We'll be splitting and welding the tooth sprockets to the shaft. There are a few things to take into account here. The shaft is very thick compared to the sprockets. And since the welds are very close to the teeth, the leverage from the belt on the weld is marginal. The maximum tensile force on each wheel is around 0.7 tons. Maybe that sounds like a lot, but a few solid tack welds would already be strong enough. We are going slightly beyond that. We also want to avoid introducing so much heat into the shaft that it deforms. But with these small welds, that won't be an issue. These sprockets are made from C45 high carbon steel, which is prone to cold cracking when welded without preheating. We can do the initial tacks cold, but the final welds require more heat. So we built a quick and dirty oven in which the shaft has to reach at least 180 degrees Celsius before we can lay the final welds. Zij zegt hier in het midden 175 en daar 380. To finish it off, we'll let the whole assembly cool down slowly to prevent any cracking in the weld. We already mounted the main engine back on its foundation, but since the intermediate shaft is a bit shorter now, it should fit right back in. If we now tighten one flange, we are still able to fit the poly chain belts through the gap, when the shaft is pushed all the way out until the mysterious obstruction. So we chose not to fit spare belts around the shaft, but we'll keep them somewhere safe and protected from harsh engine room environment. For the Tesla motor, we had a new small shaft machined that fits exactly on the drive shaft stump. In this case, we don't have to do anything radical because the sprockets just fit on the shaft.
Ja, hij houdt straks
In een lager, ja, ook.
All we have to do now is fit an extra bearing so that the radial load of the belts is nicely divided over both ends of the shaft, to not get crooked forces inside the Tesla gear.
even een kooiboes om halen. Ja.
The foundation needs some final adjustments and then the whole thing can be installed.
Als het goed is kan je er nou recht
Onder.
onder. Ja, laat hem maar een stukje zakken, want die andere die kan er van achteraf, van de opzij af ingeschoven worden. Oké. Nog omduwen.
Alignment of the motor is a crucial part, especially since we have two belts, so that one of them does not take all of the load. We cannot just do that on site, so we're installing adjusting bolts in every single direction that we might need to adjust the motor. And there we go, one electric motor in place. This was only the mechanical part of the installation, but we are pretty pleased with how it turned out. Next, we're gonna need some big batteries, wiring and motor controls, but that is for the next time. And this is all for now. If you have any questions or remarks, please let us know in the comments. Thank you for watching and I'll see you next time.